Hey guys, we're going to start with section B, interval notation for chapter 2. I got my little helper with me, my son Caden. There he is. Okay, that's good. Oof, he's going to drop some stuff. So, what we're going to do with interval notation, we've pretty much covered a lot of it, but I'm going to do a quick review. I'm dropping stuff too. As you guys all know these symbols, we have greater than or equal to, less than or equal to. On a number line, you get a solid dot when it's the greater than or less than or equal to. If it's greater than, I have a hollow dot. If it's less than, I have a hollow dot. So what we're going to do is we're going to write this in set notation or interval notation, depending on the book you're reading. Remember, Z's going to be integers. Z positive is positive integers, natural numbers, and Q rational. So we get to decide, I forgot this one, real. Because real includes fractions and decimals, and Q is actually, is rational.
That's supposed to be an R.
It is. It's a funky R. It has 2 lines on it. So we're going to look at the first example, which is kind of in the textbook, but not really. We want to write this in interval notation. So here's an example of interval notation. We'll get to that question in a second. This first one, we look at the number line and we decide, okay, this number line is called X. So that's where this comes in, X. And what we're talking about is our limitations. Well, 1, these are all the possible values of X. So 1, solid dot, less than or equal to X, hollow dot at 5, so it's less than 5, and it's a solid line, which means I can include all the decimals and everything else, which means I have real numbers. So X is an element of the set R. So that's the first one. The next one, we're going to get in between here. We have our number line again, and it's still X. So the same deal, X. Now, 1 is the end. Just like this, I'm going from 1 to 5. So 1 is less than or equal to X, because it's a solid dot. These are all solid dots, so I'm still going to use less than or equal to 5. But now here's the difference. These are all positive integers because there's no numbers in between. So X is an element of the set Z positive. Now, we're going to go to the third one. Caden's going to answer this, and what he's going to do, pick a side. He's going to take this, which is what we were doing here from the graph, but he's going to take this and put it on the graph. Now, I will tell you this, if it doesn't state whether it's a natural number, an integer, positive integer, rational, it's a real number, and a real number is used when I connect the dots. So Caden's going to give this a go for me. He's going to take this and graph it.
I don't really get it that much.
Okay. So where's the bottom end of this?
The bottom end would be -3.
So I make a dot right there at -3. Big dot. Kind of like I did up above. Okay, perfect. And it's a solid one. Because the less than or equal to, that's why it's a solid one. Now what's the other end of the line?
+2.
Right. And is it going to be solid or hollow? You look at this.
Hollow.
Hollow. And now, because they're real numbers, that means it's a solid line. So I just connect the dots. Awesome. And that's it for section B.